Can you solve this Math Olympiad problem we have on the board? Okay, to solve 3 power x plus x is equal to 30. If you look at this very well, you can now see that the method we are going to use is the Lambert W function. And Lambert W function states that whenever we have the W of the Lambert W function of a exponential a is giving us what? A is equal to what? A. That means once you multiply a to an exponent of that a, the output is what? Is what? A. So all our goal here is just to express this whole term to be in form of something multiplied by e of some of that thing so that we can get the answer to be A. So that's what we are going to do here. So what do we do? First, we have to isolate the exponential terms. So we can now write to be 3 power x. We are subtracting x from both sides is equal to 30 minus x. Okay? So if we have this, we can simply divide through by what? 30. Divide through by 3 power x. So if I divide by 3 power x and divide through by 3 power x, I will now have everything will now cancel. I will now have that 1 is equal to 30 minus x divided by 3 power x. Okay? So if you have this, now you can now see that we can now write it to be that 30 minus x multiplied by, this is now 3 divided by 3 power x, which is basically 1 over 3 power x, which you can now write as 3 power minus x. Okay? Because if you have a negative power, it's just 1 over, so nothing changed. And that's equals to what? 1. Okay? So if we have this one now, you can now see we are trying to make, this is now 3 power x, very close to this. So all we have to think of now is how to get, we need the multiplier 30 minus x to be exactly as the power of 3. So all we need to do here is just to what? Is just to add 30 here. And remember, once you're adding 30 to this, you are just multiplying it by 30 by the base raised to power 30. So we have it as 30 minus x multiplied by 3 power minus x times 3 power 30 so that we can get the powers to be the same is equal to 1 times 3 power 30. Whatever you do to the left hand side, you should also do it to the right hand side. Okay? And this will now give us that. And this will give us 30 minus x, then 3 times 3 power minus x plus 30 is equal to 1 times 3 power 30 is basically 3 power 30. Actually getting closer to the Lambert W function standard. But unfortunately, in Lambert W function, we make use of e, not just 3 power 3 as we make use of e, not just the 3. Okay? So we are going to rewrite this 3 to be in terms of the exponent. But you know basically that when we have e to the power of ln of what? Ln of a, that the answer is what? A. Okay? So for the 3, we can now write it to be in terms of e to the ln of 3. And that's equals to what? 3. Okay? If you understand this, we are going to apply it here. So what do we have? We'll now have 30 minus x, ln of, exponential ln of what? 3, then to the power of minus x plus 30 is equals to 3 to the power of 30. Basically, but what we have just done, we can now write this to be, this is because ln of e to the power of ln 3 is equals to 3. So this is just exponent and they are multiplying. So this two is multiplying themselves. So we can now have it to be 30 minus x into ln of, since these two are exponent of, since these two are multiplying, I can now have minus x plus 30, okay, ln 3, because multiplication is commutative, and this is equals to 3 to the power of 30. Okay, since you have done this, you can see that this simple thing we've done have now changed this, because we need ln of 3 to be here so that we can apply the Lambert W function. So what do we do? What do we do to get ln of 3 here? We'll multiply both sides of the equation by ln 3. So we have 30 minus x, okay? Then ln 3 exponential minus x plus 30 ln 3 is equals to 3 power 30 ln 3. Okay? Now we can now apply the Lambert W function. So if you're applying the Lambert W function, we'll now have something like the Lambert W function, because this term and the power is now the same. So we'll have it that Lambert W function, the Lambert W function of 30 minus x ln 3 of exponent 30 minus x, still the same, ln 3, okay, that's done, is equals to the Lambert W function of 30 power 3 power 30 ln 3. Okay, so you can now see that the output here will now be, all these are just like A. So all this will be the output. So we have it as 30 minus x ln 3, okay, is now equal to the Lambert W function of 30 3 power 30 ln 3. Okay, that the W function, we are just dealing on the right hand side of, so instead of writing 30, I can write it as 3 to the power of 3, then times ln of 3, then times 3 to the power of 27. Remember, if you're multiplying in the same base, you just have to add the powers and everything becomes the same, right? So if you have this now, 3 power 3 is 27, right? So we can now have it as W of 27 ln of 3. Then we are having this 3 now. So remember, when we have exponential ln 3, that is the same thing as 3. So I'll replace this 3 by exponential ln 3. So I'll write it as times exponential ln 3, then to the power of what? 27. Okay? So if you're having this, you can now see, what do you observe? What do you observe? What do you observe? We have it that the W function of 27 ln 3 times exponential ln 3 times what? 27, which is just the same. So you can now see, if you also take the W function of this, you can now see we have the total to be 30 minus x ln 3 is equal to what? Is equals to, if you, the W function of this gives 27 ln 3. So we'll have it as 27 ln 3. So here, what do you observe? This will cancel out this. ln 3 cancels out on both sides. We have it as 30 minus x is equal to 27. So for us to get the value of x, you can now see that x is equals to 30 minus 27. And 30 minus 27 is 3. So we basically say that the value for x is just 3. So the value for x in this particular problem can only be 3. If you found the video helpful, do not fail to like, comment, share, and subscribe. See you next time.